entering in this meeting. Some might not have posted, but that is fine. They can tell their questions now. They can ask in the chat window or they can speak the question. Absolutely no problem for us. However, because we have some questions already posted by learners, we will take up those questions first. Okay. And subsequently, we will answer and we will have interaction with everybody whosoever is there in the meeting. So there are only very few persons in the meeting. Some may join maybe later also. So we will take up questions from everybody. Time permitting, we have kept 2 hours. That should be sufficient. We can even go beyond 2 hours if it is required. Yeah, so along with me, we have also Mr. Abhishek. He is one of the TAs who is helping me in this course, in conducting this course. So I welcome Abhishek. And I can see on screen, we have one Nalini. Nalini is joined in 2 names. So I do not know it is same Nalini in both the names or 2 different persons. One is joined as Mr. Girish and one is like Amarendra Reddy, some Kumar Prabhakar from IIT Madras and Dr. V.S. Krishnaswamy. So welcome everyone. Now, Dr. Amarendra Reddy.
Yes, sir.
Your question, you have given a question to understand that Euler's method and Ruge-Kutta method.
Yes,
right?
sir.
So I just request you to hold it for a moment. I will take it up later. Other people have very shorter questions and some clarifications only. So I will take up those things first and then I will come to your question. Okay. Please allow me to do that. Okay, now coming to Nalini. Nalini,
yes,
what questions you have posted? Could you... So, Acha, Nalini has doubts about the assignment questions. Okay. Is that correct?
yeah, sir.
Yeah. So, assignment, is that your question? Assignment 5, question number 6 and 7, procedure to solve the question and the solution. This is what you have written or somebody else has written? Sorry.
Yes, yeah, I have a doubt in assignment questions only, sir.
Yeah, could you once again repeat your statement? Sorry.
Sir, I have doubt in our assignment questions.
Yeah. So, could you please tell what was your question? Which assignment and what was the question?
Sir, first, the thing is inverted pendulum problem in first and second assignment. Inverted pendulum.
Okay. Just a moment.
How to form a state equation for an inverted pendulum?
Yeah, I am just sharing my screen, then you can tell which one is that. I am sharing that assignment on the...
Assignment 1 and 2.
But how to share that, yeah?
That's share. Share screen.
Yeah, I'm doing. Oh, there seems to be some setting issues. I am trying. Just please give me a moment. Oh, it was open now. I think it is this one. So is it shared on screen? This one. Yeah, I think it is now there on the screen. Yeah. Could someone confirm?
Yes, sir.
Yeah. So which question, Nalini? Excuse me, please. Inverted pendulum she was telling, na? So which is that? Mass. This.
Last one, sir.
Okay, I am scrolling. Yeah, this one. Yeah, now please tell what was your question exactly?
Sir, actually, for this 19th problem, I can able to do, but 20th problem, because they.
Which one you could not do next?
Yeah, sir. This one.
Double pendulum. Okay.
Yes,
Yeah.
yeah, sir.
Yeah.
I can't able to do this, sir.
No, why? What is the problem? Means basically one has to make the free body diagram, and then considering M2 first is the easiest. So there is a force UT in the horizontal direction, and that string will have tension. So one has to assume that tension, and there will be a downward force M2G. Okay. So that UT, one of the components, means either UT can be broken into two components, one perpendicular to that string and one along the string. So if this is theta 2, then this is 90 minus theta 2, and UT sine theta 2 and plus mg m2 into what will be that force? Either sine theta or cos theta 2, that will be equal to the tension in the string. Yeah. Yeah. Okay. Now we can share only one of the two at one time. So probably this we will have to stop sharing. Okay, we have seen the question. Let me share the board. There was open board. So I want to share the open board. Will it be visible? No. Let us see whiteboard. Yeah, see if you are able to. Yeah, it will work. So will you tell? Yeah, so Nalini, what I was telling, this is the string, and you have to assume a tension T in the string. This is the bob. Its force is M2G, which is working down. And there is a force U applied on this, right? So M2G has two components, one in this direction. This angle from vertical was, I'm not remembering in the figure, it was theta 2, I think. So this is mg cos theta 2. And this U has two components. One component is like this, which is U sine theta 2. And one component will be like this, which is U cos, which will be sine and which will be cos. I think there is a doubt. This is 90 minus theta 2, and this is theta 2. So this seems fine, U cos theta 2. Now these are the forces, to be balanced. M2G cos theta 2 is also, sine theta 2 is on this side. Okay. So the force, that if you consider that M2 and into radius will be what? What was this length of the string? L2 probably. So M2 L2 theta 2 double dot. Okay, this is the other force. Now they are to be equated. M2 L2 theta 2 double dot will be equal to that U cos theta 2 plus M2G sin theta 2. This will be one equation. Okay. And that string force will match. That T will be equal to rest of the forces. So that T will be, T plus U sin theta 2. No, U sin theta 2 is in the opposite direction. I'm sorry. Where is the eraser? This one? Yeah. Pen, which is
Sir,
pen?
can you repeat the same thing, sir?
Which thing you want me to repeat?
Again, can you explain free body diagram one more time?
Yeah, okay. So what I was telling that this is the string, right? By which it is attached to the other bob. Other bob is here. And this angle is theta 2. Now there will be a tension in the string which is assumed as T, right?
Yes, sir. Yes, sir.
There is a downward force M2G. This is the force of that weight. Okay.
Yes, sir.
This is the weight. Is my pen visible there to you?
Yes, sir. Yes, sir.
Okay. Then this M2G has two components. One component shown this one M2G. Sorry, I forgot 2 there. M2G cos theta 2. Okay. And other component is this way. This is M2G sin theta 2.
Theta 2. Yes, sir.
Okay. And U can be broken into two components.
Yes,
One
sir.
along the string and one perpendicular to the string. So U cos theta 2 is one force like this. I think the arrow I have shown is incorrect.
Yes, sir.
Arrow should be that other direction. And U sin theta 2 is the force opposing in the tension in the string. That is U sin theta 2. And all these forces, because the bob is moving on an arc like this, right? That this arc which I showed dotted here.
Yes, sir.
So it has a force of inertia, which is that it is torque into. So it is this one. This is theta dot is angular velocity and theta double dot is angular acceleration, right? So, and mass into L, that length is the moment of inertia in this case. So M2 into L2 into theta 2 double dot is that force or torque creating that acceleration of the bob. So that should match these forces. Only I have to now invert this sign because this is the other way around. It is helping. So minus U cos theta 2 plus M2G sin theta 2. This is the opposing force, and that should result into the acceleration. Okay. Okay, I think there is some stray sound that we can leave. Now, that other one will be a torque T will be obtained by balance of the forces in this direction. So one of them is M2G cos theta 2 and other one is U sin theta 2. So T is U sin theta 2 plus M2G cos theta 2. Now with this force, we should consider that other bob.
Sir, this one M2G side cos theta 2, no, sir?
Yeah, because this angle is theta 2, so this will also be theta 2.
Yes, sir. This is you have written sin theta 2.
Which one?
You cos theta 2.
Yeah.
Okay, okay.
Yeah, means
Ah.
you can take care if some some trigonometry error is happening, you can correct it yourself.
Yes.
So I think it is u sin theta 2 because for that the angle is 90 minus theta 2.
Yes, sir. Yes, sir.
And for mass it is theta 2. So that is why they will be different. Now this force is actually working on that other bob. Here this is T and this T. Any force was there? I don't remember. Any force was there? Nothing was there, no? So this has angle, theta, and it has its own mass, m1g. That's all. So this T will balance this T, and just its acceleration is m1g theta 1 double dot, that length also, this L1. So M1G L1, excuse me. M1G L1 theta 1 double dot will be equal to that T. There was a difference in angle, this angle is different and this angle is different. Excuse me, let me correct that. So see, this T was at different angle, right? So this was at theta 2 and this is theta 1. So this T and this T we have to consider different. Okay, so this T and this force along this direction will be T, and this is I do not know how much this angle will be. So this is T cos theta 2, this is T sin theta 2, and then we have to link to theta 1. I'm sorry, my trigonometry, knowledge is coming insufficient, but we have to assume some alpha here, and we have to get the component of T which is coming in this direction. And that one plus that component of T in that direction, that should match this mg, and this is cos sine, m1g sine theta 1. Okay, this is the kind of equations we have to write. Nalini, are you there?
Yeah, sir.
Yeah, so this is the kind of equations we have to write considering the torque and forces. And I request Abhishek will probably, in consultation with me, he will make a fair of this. And meanwhile, you also try, and then we will ask NPTEL to post it to all candidates. Fine? We'll do that.
So some of the problems I can't able to solve. Can you able to put the solutions for the problems?
So, yeah, I think some other person has also written this thing. Let me first remove this so that I can be in the meeting properly. How to do this? Unshare now, this one. Yeah. So Nalini, there is one more person who has written that we should share the detailed solution. In fact, he has written detailed solution to all the assignment questions. So what we will do is that it will require a lot of time to make detailed answer to prepare in the LaTeX document and post that. That will take a lot of time, but we will put the correct answers are known to them, no? Correct answers are known. So what we will do, we will prepare hints, okay? and we will ask NPTEL to put it to all the candidates. That we will do. Will that be okay? And if still it is not possible, with the help of the hints to get all the solutions, then some questions we will give the solutions also. Like this one we will solve and we will ask NPTEL to make it available to all the candidates.
Sir, actually, I am the one who asked to post the detailed solution.
Yeah,
Sir, as you just said, if it is possible in most of the assignments, there is one standard problem, and based on that, there are multiple problems,
yes.
linked questions, right? So, if you can just provide solution for one of the questions, then remaining questions we can go through that. I mean, we can
Got it.
obtain from that.
Got it. So that means the method which I suggested is acceptable to you, that we will put hints and in some cases the detailed solutions, right?
Okay, sir.
Yeah. So through the help of NPTEL, we will get it shared to all the learners.
Sir,
Okay.
another one query. Full state observer and reduced state observer, for that, which book to be followed, sir?
Once again, please repeat which topic?
Full state observer and reduced state observer, week 8, sir.
Yeah, so in most of the situations, I have been following the book by Friedland. In some videos, I have given the complete reference of that book. However, both the topics are there in all the books. Any textbook we pick, it is there. So if you see the book by M. Gopal, it is there in that. In the book by Kuo, it is there. In the book by Ogata, it is there. I do not know whether it is there in Chen or not, but these books it is there. But I followed from Friedland. Did you see that reference, Friedland's reference?
Sir, introduction to state space I have referred, sir. In that, it is not clear, I think. But another one book you have told in Friedland, Advanced Control System.
No, in advanced control system, it is not there. In Friedland's that introduction to state space methods, I think that is the title, it is there. Okay.
Okay, sir.
In fact, I have followed exactly that book. Only the examples may be different, or maybe examples also from the same book. I do not remember exactly, but that is the book. Sometimes I followed one book by Schultz and Melsa. So, but I think this topic was taken from Friedland.
Okay, sir.
Yeah. Okay, so Tejas had one more question, I think. Dr. Tejas? Yeah, somebody has written, will we be allowed a sheet of formulae for the final exam? This somebody has written. And the answer to this question is no, because we expect people to remember the formulae, and there will be some questions memory based. So you have to recall from the memory and write. One will not be allowed. There is no standard. Who will bring what? We will not have any control. So that is why we will not allow. And this will be, one person has asked whether it will be online exam or offline exam. Somewhere it was there. I'm not able to see. Yeah, see, somebody has written, is it possible to provide PPT separately? Then second question is, in the examination, whether they provide MATLAB for solving problems. Then is the exam MCQ or pen paper exam? Whether they allow physical calculator in exam. So let me answer first. Is the exam MCQ? The answer is no. This exam is not MCQ. This will be subjective type examination. Detailed workout, detailed answers, as you think, you have to write on you will be provided paper. You have to bring pen. I do not know. They may provide pen also. NPTEL, do you provide pen also, or candidates have to bring the pen?
No, sir, we have to get the pen by ourselves.
Candidates have to bring their pen, pencil. However, paper will be provided. So,
Yes, sir.
They have to write, all the candidates have to write the detailed answer, how to arrive the answer. And based on that, because in MCQ, little error will not lead to answer, correct answer. So here the candidates will have better scoring opportunity. That is why we have given subjective type questions and short answer type questions in the question paper. So this is a pen paper examination, not MCQ type. There will be short answer type, there will be long answer type.
Sir,
Physical calculator is not allowed. Let me complete, then we will come. Physical calculator is not allowed. We have provided on-screen calculator. You will see the questions in a computer screen, and there will be one on-screen calculator which will be possible to operate using the mouse. So candidates will be able to use that. Then MATLAB or no access to internet will be provided. So you have to do hand calculations using the calculator. And is it possible to provide PPT separately? So far we have not shared the PPT. However, I am thinking that I will share to candidates who will be appearing in the examination, only to those candidates. Not to every learner, only to the candidates who are appearing in the examination, we will share the PPT. This is what we have decided. So I have answered the 4 parts. I do not know the person who asked the question. Is it Tejas? Excuse me.
Yes,
who
sir.
asked this question? Did you ask this question?
Which question, sir?
This question is
PPT.
PPT.
Yes, sir. Yes, sir. Yes.
Okay,
Sir.
so I have answered. So
Yes, sir.
that way it will be. Okay.
And sir,
Now-
one last thing. One last
Yeah,
thing,
yeah,
sir.
Yeah.
Sir, actually, in the assignments, the question which have been asked, those questions are, I mean, lengthy and very difficult to solve by hand calculation. So most of the problems we have done through MATLAB. So if you can provide 1 or 2 sample problems which can be asked during the examination, so it will be a great help what to expect.
Okay, thank you for this question, and through answer to you, I am answering to everybody that see, generally we prepare assignment so that any learner will face difficulty in answering assignment. This is generally done because assignment is not meant for just attending the video lecture and answering the assignment. No, you have to do some study subsequent to lectures also, because this is a postgraduate level course. So it is expected that after the lecture, people refer to the textbooks and they do some extra effort in order to be able to complete their learning. It's not alone based on the video lectures that a person get the full knowledge. So assignment questions are generally made little tough. And sometimes in the assignments you will have 5th order problem, 4th order problem, like that, which definitely require help of MATLAB. So that you have done, that is perfectly fine. Coming to examination, there will not be a need of going to MATLAB. It will be possible for you to do the workout and get the answer through hand calculations and by using the calculator. So access to MATLAB is definitely not required. The questions potential is not that great as it is there in the assignments. Many questions are really, we have set it that way so that they are required to, they will require the computational software like MATLAB. So I think that should give you enough hint, and to other people who are in the meeting, everybody should get the enough hint that we have set the question paper in such a way that there will not be any need of any computational software.
sir, is there any choice, sir?
Choice means?
So maybe 8 out of 5 or 12.
Acha, okay. You mean, yeah, that is there. Choice is there, enough choice is there, in fact. So question paper, you will definitely find easy compared to assignments.
Sir, as you told, I'm preparing from the book only because by using book only, I can answer the assignment questions. But the thing is, in some of
And
the weeks, you have.
Nalini, excuse me, you are
Yeah,
speaking
sir.
fast. So if you give gap between your words, speak little slow, because in the online meeting, we are not able to get the complete sentence. So please
Okay,
speak
sir.
little slow pace. Okay.
Okay, sir.
Yeah, please
Sir,
repeat. Yeah.
I'm referring the books as you told in the every video, but in some of the videos you have not mentioned the book to be referred. So that I have searched for the books and I can't able to find that particular topic in the book. That's why but I kindly request you to mention the book to be referred in each week, sir. Thank you, sir.
Okay. Yeah, I got your question. So see, first few chapters, they are found in all the books. So like mathematical modeling examples exactly may not be found in all the books, but at least the assignment problems you will find in books, certainly. That is one. Then comes to solution of state equation. It is there in the books. Controllability, observability, it is there in the books which I have suggested and in all the books. Stability, in most of the books, it is there. Pole placement design, LQR design, observer design, this is there in the books. Now, after that, when it has come to multi-rate controller, that is not found in the book. That is taken from papers because those are based on the research in 80s or later. And remaining topics are based on the research earlier to 70 or maybe around 70 plus minus 10 years, around that. So these topics, new topics, multi-rate controllers, I'm sorry. So multi-rate output control, fast output sampling curve control, periodic output feedback control. These topics, they are from papers. So did I not suggest the references? If I have not suggested, I will send to NPTEL and NPTEL will suggest it through some kind of a PDF file, right? That will be done. Okay. And
Sir, can I ask one question, sir?
yeah, just let me complete that answer. Please hold for a moment. I have to speak one or two more sentences to Nalini. This last two lectures, I mean 2 weeks is on a case study of nuclear reactor, which will be probably done in the coming week and the next week. So that is definitely not found in any book, and there are some paper publications by me and my co-authors and some Korean authors. You will find some papers. So definitely you have to refer to the papers. Okay, so that is the thing, Nalini.
Thank you, sir.
For those three topics, if it was not told in the lectures, then I will share the details.
Thank you, sir.
Yeah. Please come on, Mr. Dr. Tejas, I think. Who is the
Amarendra.
Amrendra? Yeah, please come.
Sir, regarding the C matrix of the MROC, multi-rate output feedback controller,
Yeah.
here, while calculating the C matrix which you have given for the in the assignments, that is today is the last date for submission. Here
That is generally it is Friday now. Why the last date is coming in the mid of the week? Acha, okay, it is extra a few days has been given.
Yes.
Okay, yeah, okay.
Sir, regarding that C calculation, C1 into e to the power of minus a into n1 delta 1. Like that you have given, sir. But while computing in the MATLAB, so since it is third order system and here we need to compute, we have computed using MATLAB, sir. C1 into e to the power of plus a into n1 into delta 1. So C1 into n1 minus 1 into delta.
Yeah, tell. Come to the point. So that's expression is different.
Regarding that one, actually you have given in the PPT minus A into N1 into delta 1, sir.
Okay.
But in the answers, while doing e to the power of plus A into N.
Sorry, your network or my network? Whose network is bad?
Delta 1, then only we are getting answers, sir. So,
see, I don't rule out a possibility of typographical error or in error in our calculation. Sometimes this is possible because assignments are prepared parallelly to the lectures. So there is a possibility of errors. But wherever learners are writing back to us, we are cross-checking and that correction is being done. And this is one very specific reason why I planned a subjective type examination, because there we can definitely see the way candidate is trying to attempt the question, and final answer may not match, but if the methodology is matching, that is what is essential for a proper assessment. So that was the reason. And in MCQ type, so basically these questions, assignment questions, they are not suitable for MCQ, but we have prepared MCQ questions so that they become suitable for automated assessment. And wherever candidates are bringing out this that some things are not matching, we do cross check and re-evaluation is being done. So you can write there, and our TA Mr. Abhishek will again solve and check, and if necessary he will share on the forum. Okay, so you can write one email, please.
yes.
Thank you. Yeah, so what else is there? Dr. Krishna Swami had so let us see some questions or some observations from other participants who are there, please. One gentleman, Sanoop, has joined. So is there anything you want to ask or suggest, Sanoop? Okay, then I think I will go to Mr. Amrendra again, that question, detailed question which was there. So only thing is that open board, can we share open board here? Possible, or we have to use whiteboard only? Okay, let us, I will require jotting down in whiteboard. So yeah, so this will take 10-15 minutes time to answer this. It is open board is coming. Is it visible to you? Could somebody?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So see, in order to answer your question, I thought of a relatively little difficult practical type of problem. So on the screen you will see this. So is laser visible to you on the screen?
Yes, sir.
Yes, sir.
Okay, so I have considered a open tank having one outlet nozzle, and inflow is coming to the tank through one control valve, right? Now I have written the model equations here. I will just explain what happens. So on this side you have upstream pressure, and this side it is open to atmosphere. So this upstream pressure minus this pressure is the delta P across the control valve. And this control valve position itself will be governed by a second order equation like this, where this I is denoting the control signal to its positioner, and Z is its position. So control valve dynamics is governed by a second order equation. This was done in the modeling lectures, but doesn't matter if you don't remember. Just grasp this point that the control valve is modeled like a second order system in this form. And K1, K2, K3 are some constants. Now this equation will be broken into two first order equations like this. Okay, so one state is the position, other state is the velocity of the control valve. So we will have this equation dz by dt equal to v and dv by dt equal to this. One term multiplied by position, one term multiplied by velocity, and other one its signal. That is, so this is two equations are for the valve, and this equation is for the this level in the tank. At any time, if the level is h, then the rate of change of level is difference in inflow to outflow divided by the cross-section area of the tank. And this inflow is given something like this, non-linear. If the valve is equal percentage, then it is given like this. K4 contains a valve coefficient and that pressure differential across the valve. And E power a small constant into the position multiplies to this. So this gives the flow in. Flow out is proportional to the square root of liquid head. So this is what is the flow out. So you have these equations 1, 2, and 3 describing this system. Now let us see how we can attempt to solve it, using the let me go to the next sheet. So I think this is for the next sheet. Yeah, so just a moment. Yeah. So if the three equations are assembled in the matrix form, you get this representation, right? Can you see that Z dot is V and V dot is linear combination of Z, V, and the input signal is I multiplied by K3, and dH by dt was given by these two terms. Now see, it has a severe nonlinearity here, okay, in the form of the third equation. Okay, and this whole function inside the matrix is denoted by one F. This is function of these three states, Z, V, and H, right?
Yes.
Now let us see how it has to be solved using the Euler's formulation. So what we do is that if you consider first one of them, so Zk plus 1 minus Zk. Okay, you understand this notation, right?
Yes, sir.
So this is the approximation for the derivative of Z, right? Zk plus 1 minus Zk by delta t. That is Vt, and that is means Vk. Okay. And similarly, the other ones. So it becomes like this. Zk plus 1 minus, let me write like this, then Vk plus 1 and Hk plus 1 minus Zk, Vk, and Hk. This is equal to, now see, this is F, but what it means is that this is Vk, this is minus K2 Zk minus K1 Vk plus K3 Ik, and last one is K4 by A e power K5 Zk minus K6. Please don't confuse between these coefficients K1, K2, etc. and that K which denotes the instant of time. If there is a confusion, I may like to substitute it by something. So is it okay if I use K for the time instant and this K1, K2, etc. for coefficients? Okay, now this is that F, right?
Yes.
And this difference divided by that delta t. Delta t is the time difference between tk plus 1 and tk. So this is the Euler approximation. And what we do is that we multiply by delta t on the right. So all the terms will be multiplied by the delta t, everything, okay? And to that will be added the previous value. Okay, so it becomes like this, that new state is the previous state. This is the new state. This is the previous state. And this is the value of function evaluated based upon the knowledge of states at the previous instant multiplied by the time step. This is how one has to basically program in the computer based on the Euler's method. Got it?
Yes, sir.
So all non-linearities are here. It could be linear, it could be non-linear, doesn't matter. But that individual function, that f1, f2, f3, all the components of f are to be separately programmed in order to do Euler's. Okay. Should I tell about Runge-Kutta?
Yes, sir.
Okay. So when it comes to doing Runge-Kutta, so you see in Runge-Kutta we had we have to find 4 derivatives. One in my lectures I have denoted as ds, meaning at the start 1, dm1 meaning 1 at the middle, dm2 and de at the end. So it is the start of the time interval. This is time interval, this is tk, this is tk plus 1. So at the start of the time interval, one has to find the function. At the middle of the time interval, one has to find the function. Again, one has to find the function at the middle of the interval and one at the end of the interval. This is the subscripts I have used to make it clear. Now, what has to do is one has to find ds. So ds is very similar to that Euler. Okay. This was using Vk and K2 Zk minus K1 Vk plus K3 into Ik. And other one was K4 by A e power K5 Zk minus K6 by A root of Hk. Okay, this is very similar to what was done in case of Euler. Now this ds is there, so one can calculate some intermediate value of state, which I am calling as xk plus delta t by 2. This one determines by using that xk, so which is zk, vk and hk at t equal to tk plus delta t into this ds. This ds, mind it has 3 components, ds1, ds2, ds3. So one gets some intermediate value of x, and let me call it some ZA, VA and HA. That A is basically for intermediate. Okay. So up to this point, it is very similar to Euler. This is the value of the function for first state, second state, third state, multiplied by the time step size delta t, that is the change in the state variable. that is getting added to respective states. This is very similar to Euler, right? I think it is clear up to that point. Are you there?
Yes, sir. Yes, sir. I am there, sir. Actually.
Yeah, so please keep acknowledging. I will get more confidence.
Yes, sir.
Okay. Now, now let us see what we are doing when we are going to. Okay, let me open the next sheet. Now, when it comes to evaluating the derivative at the middle point of that time step, then that is denoted by dm1. Okay, and that is, now you see what happens. Straight away I am going to the explanation. We obtained VA, ZA, and HA, right? We obtained
Yes,
in
sir.
the previous page. You
Yes.
please remember. So dm1 is the value of function, each component evaluated using these state variables. That is all. So otherwise it is like Euler. So we have that z dot was velocity. So it will be substituted VA, that the evaluated value in the last step. The second one was K2 into Z, so it will become K2 into ZA. I think there was a minus sign here. Then K1 into VA plus K3 into I at this instant. So KT plus delta T at the middle, because that input is known. So we have to use the value of excitation at the middle of the time step. Okay. This is what has to be done. And last one is K4 by A and e power K5 ZA. It was position here, minus K6 by area. It is root of H. So it is HA. So do you see what has been done? That intermediate value which was calculated, that is used to calculate this derivative.
Yes.
Okay, and now we again determine ZB, that again the solution at intermediate step once more. ZB, VB, and HB. I am calling by subscript B. So this is similar, that ZK, please remember, it is not ZA, and VK and HK. At T equal to, TK, it has to be taken, plus delta T by 2, because we are evaluating at the middle of the time steps.
Yes,
in
sir.
dm1 first, dm1 second coordinate, dm1 third coordinate. So this is dm1, it is brought here. This is dm2, it is brought here, and this is dm3, which is brought here. Okay, so we again calculate the value of states at the midpoint. And these values will be used to calculate dm2. So everywhere in place of A, you will have B. Got it?
Yes, sir. Yes.
And the value of current again at the midpoint. Now dm2 is obtained. Now finally DE will be obtained. So in DE again the things are identical. DE will be, now we have obtained ZB, VB, and HB. So using that we calculated, we got, we use this, we get dm2. And using dm2 here, we will get ZC, VC, and HC. Means once again we are calculating, and then we evaluate DE. So it will be VC K2 ZC minus K1 VC plus K3 that I, now it is at K plus 1T, that value of current. And K4 by A e power K5 ZC minus K6 by A root of HC. Now see what we are doing, that intermediate solutions we are substituting in that function f to obtain the slope.
Yes,
And now we have ds, we have ds, we have dm1, we have dm2, and we have de. So we plug these values into the formula and calculate the thing, right? So it is there in the previous one. Somewhere I wrote the formula. Oh, sorry, I'm not.
ds plus 2 dme 2 dm1 plus 2 dm2
Correct. So there we plug these values, and that makes one iteration of Euler. Runge-Kutta. Now you have to use that knowledge of states at K plus 1 to get the states at K plus 2, and again you will do 4 calculations.
Yes.
And so on. So I think it will be clear. Otherwise, I will fare and ask NPTEL to share it to the people, my notes. Okay.
Can you share these notes, sir, so that
This will be shared.
yes,
I will send to NPTEL asking them to share to all the candidates.
yes.
Okay. Yeah, now anything else is there? How to stop sharing? Yeah, here. Yeah, so you have any other question, or we can take questions from any other member?
Sir, regarding stability, sir, Lyapunov stability,
Yeah,
that first order, whenever we have the modulus is given in the assignment problem, sir.
I think again you had written, just a moment. We have one question, I do not know.
Sir, we are not audible, sir.
Yeah, sorry. This is, I am trying to share the assignment to you. So, did it get shared?
Yes, sir.
Yeah, no, somehow my side the screen has become so small, I'm not able to see how to go there. Oh, somehow my side screen is not visible to myself.
So screen is visible to us, sir.
No, that's fine, but I should be able to see my own screen.
Not notebook, this only this page is sharing.
Just a moment, I will stop share, and then after sharing something happens. So yeah, now I think I'm able to see the members on video and also the assignment. So Problem 6 I have shown on the screen. Is it there?
Yes, sir. Yes, sir. That one
This is the
only.
problem probably you wanted to discuss now.
Yeah, yes, sir. Absolute
Yeah.
value of, so I have doubt on this one, sir. Whenever absolute values are present, how to solve the problems or some non-linearity is present.
So I think this problem is solved in one of the books, but probably you did not get that book. Okay.
Yes.
So because of the mod, probably you will be feeling the
Yes, sir.
difference.
Yes.
Yeah, that modulus. So we will share the complete solution of this in a day or two. Okay.
Yes, sir. Yes.
This and 7th, right? Both you want.
Yes, sir.
Okay. We will share the solution. So these two and that double pendulum solution we will share, and also these notes on this example, Euler and Runge-Kutta example.
Yes, sir.
Yeah, okay. So in 2 days we should be able to share. We will do. Yeah, so let me remove this from the screen and we go to some other query. Yeah, so you have completed or you have some more queries?
Cart problem, we have to refer which textbook, sir?
Card problem is
Bogota is there, sir.
Bogota also it is there. Yeah, it is there. So basically, you have to see a few textbooks. Assignment problems are taken from books only, books here and there.
So in the cart problem, you are giving.
It is two cart or single cart. Which one you are telling? Cart, inverted pendulum on cart?
Yes, sir. Yes, sir. Inverted pendulum on cart, sir.
It is there in Chen's book also. CT Chen's book, it is there. Yeah, tell.
Sir, several types of the modeling is present. So we are confusing which model to be followed.
See, basically, you have to systematically follow the steps from any of the books. That card problem is a very famous problem. It is there in the Friedland's book. It is there in C.T. Chen's book. It is there in the books of all the Indian authors. And it is there in the book of Quakernack and Sivan.
Yes.
That linear optimal control.
Different persons assuming different assumptions.
So some people, no, assumptions are similar, but once you follow from one book thoroughly all the steps, then you will be able to follow from all the books. Essentially, it is managing the forces acting on that center of the what we call bar, that inverted pendulum.
Centroid.
So in some cases, they consider the center of gravity of the bar and the pendulum at the center of the bar. In some cases, they consider entire mass accumulated in the ball itself, the bob. That is one thing. Some people have modeled using energy approach, which we have not discussed. Energy approach in this case gives a easy solution. However, most of the people have done the way we have gone. We have to see the forces and torques, and we have to balance them.
Yes.
So then the solution is arrived at. And it is solved actually. It is solved in, I think in Friedland, it is solved. I do not know in that change. But notations and the angles, etc., they are shown differently, and that is why you will find that one author's things do not match to other authors' position of the same topic actually.
Yes.
Yes. So we take up some other people. Nalini, you have any other question?
Sir, I have a question related to how to find a stability and detachability easily by seeing a matrix. Can I able to do it,
Stability and
detachability?
detectability. Okay. So detectability is basically, it is offshoot of observability. Let me share the whiteboard. Where is the whiteboard? So this one? No, this one. Yeah. Some other page, how to go? How to get a fresh page? Delete. Okay. Okay. Yeah. So thank you. So see, detectability and observability are very close. So like, let me start with x dot equal to ax plus bu and y equal to cx. This is the way we consider our system. Now we say that system is observable if rank of this matrix, this some p matrix, I may be using different notations, but that should not matter. CA square, etc. CA n minus 1. This system is observable if rank of this matrix is n, right? Now suppose its rank is less than n. Okay. Now there we see that if its rank is less than n, then it is not observable. Okay, that is the immediate conclusion. Okay, but then if we decompose it into two systems, XA and XB, I may be using different notations, but please bear with me. So some A11, A12, A21, A22, XA, XB plus B1, B2, U and Y equal to C1, C2, XA, XB. Now suppose we decompose using the linearly independent columns of P and some assumed columns. Okay, so what we do is that we synthesize a matrix T, which is all the linearly independent columns of this P, independent rows of this P, which is the upper part, and T2 we select arbitrarily. So there is no unique solution. One has to have, choice of T2 so that this T has full rank. Okay, so T1 is linearly independent columns of P, rows, excuse me. I confuse and end up using the controllability terminologies. So I was supposed to erase the columns. Yeah, so T1 is linearly independent rows of P. Okay, and those are N1. And remaining N minus N1 assumed rows. And this assumption has to be done so that this T will have the full rank, right? Now, when we do that T inverse AT and T inverse B and CT inverse, then we will get this kind of decomposition in which, this C2 will become 0 and this will become 0 most probably. I may be confusing, one of these two becomes 0. Okay. Now, but then Y is of this form. This C2 is 0, so only C1 is there. Now, this A to 2, you see, this XB corresponding to that, C2 is 0, so it is not reflecting in the output. Okay. Now, if this A to 2 is a stable matrix, if eigenvalues of this part of the matrix are having negative real parts, then those states will not reflect in the observation. However, those states will decay with time, and so XA alone reflects the system behavior at t tending to infinity. And so this system will be called detectable if A22 is stable. However, if A22 is unstable, then it will not be called detectable. So if you don't have to follow the mathematics, if you have to only say in words, then we say like this, that we have a system and it is not observable. So not observable doesn't mean that every state is not available. So it is not observable by being, by having the observability matrix of rank n1, which is less than n. Then the system will be called detectable if the unobserved dynamics is stable. This is in the words if we have to say. Okay, and in mathematics, it means this, that this is the unobserved dynamics, this is stable. Yes, Nalini?
Sir, in case of observability index also, we are doing like this only, sir.
Exactly.
Okay, sir.
So we first determine the observability index, which is N1 here. And then we go on to break this system into observable and unobservable system. So XA is observable, XB is unobservable, but because A22 is stable, so it is whole system is detected. Yeah, I have completed.
Sir, in case of stabilizable, if the eigenvalues are positive, then it is on the right side. Is it correct,
Yes,
sir?
yes. So I do not know this one. So basically that concept I have taken from the classical control, that if this is the real axis and this is the imaginary axis, then if any pole lies on the right of the j omega axis, including the j omega axis, if anything is on this side, then it represents the region of instability. There is an exception for only first order system, but for two poles, if they are on j omega axis, then also the system is treated to be unstable. And this is the region of stability. It excludes the j omega axis. And then this whole region is region of stability. Now, if a pole is in region of stability, means if some pole, I think in the class I have been using the notation lambda, let me use the same notation. If some lambda I, which is represented as sigma I plus j omega I, now if this sigma I is negative, okay, then it is in the left of the, this is in the LHSP, this is left half S plane. This comes from the classical controls. And so it is in the region of stability. So if the submatrix A22, after that controllable canonical decomposition, if the submatrix A22, we do decomposition, then the system becomes this. A11, I think one of them is 0. So this is 0. No, this is 0. Sorry. This is A11. Oh, excuse me. Let me clean work. So A11, oh God. A11, A12 0 A22 XA XB plus B1 and 0 U. Okay, so this is the system after doing the transformation, right? Now A11 and B1, they represent a controllable pair. However, A22 has its input matrix 0, so A22 is uncontrollable. And there we say that eigenvalues of A22, if they have negative real parts, then this system is A22 is stable and the whole system will be called stabilizable. That is the notion. Got Nalini?
Yeah, sir.
Yeah, okay. So thanks. Yeah, so we can take up some more questions. Yeah, some new members have joined. I welcome them, like one Mr. Rahul Rao. Then there is somebody with the name of Redmi Note 1. Definitely it is not his name.
Sir, my name is Anup. Actually,
Yeah,
first time when I was there in the office, that's the reason I am not able to put on the mic. Now I came outside.
no problem. Yeah, so now you can ask if you have to ask anything, or Mr. Rahul, if he has to ask anybody, please come one by one. You can ask your query.
Sir, in that, can I ask, sir?
Yes, please go ahead.
Sir, yesterday when I am just solving that multi-rate, yesterday's class problem, sir. In the class problem, finally that open loop poles and all we are able to calculate it. But when I'm just trying to find the phi, actually phi is equal to e power a into t naught. Like that way only we are just computing. But
Right.
that matrix what sir has given in the class, that we are not able to get it, like 0.99 that value, sir.
So some you mean numerical error is happening, means numerical value is coming different.
Yes, sir. Numerical value. Actually, that phi value I have computed by e power a into t naught.
T0, yeah.
T0, I have taken it as a 0.2 seconds. And the same thing what you have. And we have, I have computed that a discrete value of a. Then I am just finding phi is equal to e power a t naught.
Okay.
But when I am just finding that phi value, what in the class, sir, you have given it as 0.9936, 0.2082, like that way. But that value I am not able to, I am not getting, like, I don't know where, because that open loop IN values, it is correct.
Let me get your query properly. So what you are telling in the lecture video, I have taken one example, and the value of phi shown in the example, you are not able to get, right?
Yes, sir. Yes, sir. And even I start solving in MATLAB also.
Okay. So see, there may be some typographical error, always possible. So we will check and we will post a clarification for this. Okay. So I got your point. See, it's not that you are doing wrong. Sometimes we also do correctly, but when we write the phi matrix in the presentation, there may be some errors in copy paste. Okay, so it is always possible that we have made some error in the making the presentation. That is possible. So I take your feedback. We will check and then we will put a clarification in the forum. Okay.
Yes, sir. Sir, one more request, sir. One more request.
Yeah.
Sir, if any because for the previous all the things, any solution manual like that, if you are getting for that assignment problem, sir, it could have been a little bit better, sir, like for our better understanding.
Yes, Mr. Rahul, actually this point was discussed, and what we have promised is that some problems where specifically the people want the solution, that we will put on the discussion forum. Some other problems or most of the other problems, we will put hints how to solve, steps to solve. That we will do.
Okay, sir. Thank you, sir.
Yeah. Yeah, so if you don't have any other query, then we can move to any other person. So who is willing to ask? Any other person, please?
Sir, earlier Sanuboli asked, sir, I am Rahul this side.
Yeah,
Sir,
please.
one doubt, sir, I missed because I was in office. This index, sir, observability index computation, when I was going through some literature, sir, it was mentioning they have to create two metrics. One starting with C and going up to C a raised to gamma and a raised to mu, another one to C a raised to mu minus 1.
Acha,
So in
yes, Rahul, actually, I should thank you because in one of the lectures, I made a small error while presenting the observability index
sir.
and the controllability index. Let me correct that through your query. Yeah, I am very much thankful to you for raising this doubt. Let me just put it correctly the way I should have put. I made one error. I was seeing when I was reviewing the video, I found that error is there.
Sure.
So see, we have actually it was told in context to discrete time system. So let me take example of take the representation of discrete time system. So this is phi xk plus gamma uk and yk equal to cxk. So let us say this is the discrete time system. Now we assemble this matrix C phi k, C phi square, etc. C phi nu minus 1. This is one matrix. And we assemble, now this is the error I did. First, let me write correct thing, then I will put the okay, we have now you see number of rows in this matrix is more than the number of rows in this matrix on the left side. So observability index is the largest value of nu for which rank of matrix on the left is equal to rank of the matrix on the right. This is what I should have told, but I made a mistake. I said that I forgot to include this C. I said the rest of the things. So I made error. I said that this matrix C phi to C phi nu. That was wrong. So my sincere apologies for this thing. This is the correct definition. So observability index is the largest value of nu for which rank of this matrix on the left is equal to rank of this matrix on the right. Is it the point you wanted to say?
Yes, sir. This is in this problem, sir. If with respect to a problem, sir, if I am taking a 3x3 matrix, sir, assume it to be a discrete system with 3x3.
Yeah.
So now normally, sir, gamma max will be 2, no, sir, 0 to 2, or it will be maximum 3x3 observability matrix.
No, this will be 3x3 phi, and what is the C matrix?
Sir, 3x1, sir. 1x3, sorry, sir, 1x3.
1/3. Yeah, so you will have 3x3 matrix. This will be 3x3 matrix. This will be 4x3 matrix.
Oh. Sir, new value, sir, how to take the mu value, sir? Like I am getting confused, sir. Sorry, sir, to ask. Because mu should be, I was thinking it should be maximum the order of the system.
I will tell you. Tell you. Let me take the case of a continuous time system so that it is easy to explain. So let me say a matrix like this. I'm taking a very trivial example, so that we easily do the calculations. Let me take a diagonal system, right? This is the A matrix. And let us take this C matrix. Okay, now I create try to create that observability matrix P, which is equal to C first. Okay, so 1, 1, 0. Next row should be C into A, right?
Correct, sir. Yes, sir.
So 110 into 100 will give 1. 110 into 0.50 will give 0.5. And 110 into this will give a 0. Okay. Now you see, if we checked first only for C matrix, then the rank is, if we stopped here with P, suppose P, this column was not taken, right? Only this was taken, then the rank P came 1. If somebody checked the rank there, because this is non-zero. Got it?
Yes,
Now
sir.
this is CA. So CA, if you check, that means you have to check the determinants 2 by 2 determinants here. So first determinant 1 takes this, second determinant 1 takes this, third determinant 1 take this. So first determinant you see 1 into 0.5 minus 1 into 1. So which is non-zero, that means the rank is 2. If you take these 2 rows. Now you move to the third row, CA square. So this is CA multiplying to this A, it will give CA into A 100. So it will give 1. And CA into this, it will give 0.25. And this will give again a 0. Okay. CA square. Yeah. So this is the third row which will be obtained. This is 0.25. Now you see the rank of this matrix has not changed. It was 2, it will remain 2 because we have a full column which is coming 0. So this matrix has rank 2 and so the observability index is 2. That is one way. Other way to say is, that definition was largest value of new for which C5 square, this rank, and C5 square, C5 cube, that rank. So C5 square is same matrix as P, its rank is 2. If you make one more row here, which will be CA cube. So this is C and this is A. So 1.25 into 100, it will again come 1. This will become 0.25 into 0.5. So 0.125 and this will again come 0. Now rank of this with this thing will also come 2. And so that is the observability index. Rank of largest new for which CA square, CA cube, etc. and the one larger row will have the same rank. Got it?
Yes, sir. Yes. Clear, sir.
So even if you go for fourth one, fifth one, nothing, no change happens. So in other way to say is that one starts with C, checks the rank. Now its rank is, let us say, new 0. Then one puts CA, checks the rank comes new 1, which is greater than new 0. So one continues to CA square, one finds new 2, which is greater than new 1. Continue going till this happens. New J is greater than new J minus 1. The moment this becomes equal, new J equal to new J minus 1, you have reached the observability index. Okay.
So, sir, we need to see the power of 5 for which the rank is maximum.
Power of?
Power of 5 matrix, 5 matrix.
Yeah, no. See, the matrix is 3. So we need not go beyond 5 square actually.
So we will go only 2, up to 2 only, sir.
Only up to 2. But I am
Yes.
telling in a general case, nth order system, you start with C, put CA square, etc. This way you go. In this particular case, you stop at CA square.
Yes, sir. Yes, sir. For nth order, we will go up to n minus 1. Sir.
Up to n minus 1, yes. True.
Maximum observability index is n minus 1.
Order of the system, not more than that. True.
Order of the system minus 1, sir.
No. C is there, na? it starts with C, etc., and goes to CA minus N minus 1.
Sir, index is N minus 1. Gamma power, no, sir?
Oh, no.
You are telling the power of the gamma for which...
no, largest value of... No. See this one which I have circled. Largest value of J for which nu J equal to nu J minus 1. So, you see, nu J, this I had taken unobservable example, but suppose this was observable, then nu 4 would have come equal to nu 3. And so 3, largest value of J.
Sir, observability index for this problem is
3. No, this problem it is 2.
Sir, can you explain one more time, sir, this how to choose the gamma value or this
Gamma, what is that?
the new value?
New value. See, it is like this. A matrix phi is there, n by n, and matrix gamma is there. Gamma ne C. That output matrix is C. What is happening? So we have C, which has P rows and N columns. Right. Now, one starts with C. Okay, and checks the rank of C. It should be P. Okay, because we are assuming all rows of all outputs are independent. So rank of C should be P.
P, yes, sir.
And that is less than N.
Yes, sir. Yes.
Then one goes to C phi.
Yes, sir.
Now C phi gives the rank of C phi is, I mean rank of this augmented matrix C and C phi, right?
Yes.
It is new 1. Okay, this 5 power 1, right? So it is new 1, which is less than N. Then C phi 2. It gives a rank nu 2, which is less than N, but the more important thing is that it is more than nu 1. Okay. So like this. Now you see the largest value of, while taking that definition, I was telling you go here, let us say C phi. Now let me use a different notation because I am using new here. Let me use L. So L minus 1. Okay. Now we get new L minus 1. We L minus 2. And C phi L, new L, now it is equal to new L minus 1, right? Now the largest value of L for which this happens is the rank, is the index. So am I wrong? So this L should be 3 in 3 by 3 case, so that L minus 1 is 2. This is the definition. Value of L for which new L equals new L minus 1.
Sir, one doubt, sir. So, what will be the difference then with respect to rank of an observability matrix and index? Because in this case, your rank also will be 2, index also is 2.
That's a very good question. It's the same thing. In case of single output system. But when you consider multiple output system, then what will happen? The C matrix has, let us say, 2 rows, C1 and C2, right? Now, if you if you first consider only one of the outputs, you consider C1, C1 phi, C1 phi square, etc. Now it may not come equal to n. It will come some new one. The rank, if you consider only one of the outputs, will come new one. Okay, new one is rank of this matrix. Okay, got it. New one is the rank of this observability matrix, which is assembled only considering one of the outputs, C1. And similarly, one can obtain new 2, which is C2, C2 phi square, etc. Sorry, this new is rank of this matrix. Okay, so observability index of first output is new 1. Observability index of second output is new. Got it? And when we talk of all the outputs together, then we have to go in a sequence. Let me say, excuse me, just a moment. So sorry, I got some phone call. So I'm back. Yeah. So what I was telling that in the multivariable case, multi-output case, same phi and C, we are considering C1, C2, multiple outputs. So M outputs. Okay, these are first row, second row. Each output is denoted by corresponding C1, etc. Now, when we assemble the observability matrix, we go like this. We will C1, then C1 phi. We will go till we get independent rows. Because the observability index of C1 was new 1, so we get this. Now we take C2, C2 phi, etc. C2 phi, new 2 minus 1. Up to that, you know, this rank is changing. It was new 1, it becomes new 1 plus 1, it becomes new 1 plus 2, it becomes new 1 plus new 2. Till that time, the rank was increasing. So observability index of output 2 is new 2. And so on. Let me write the rest of the part of the matrix here. And so on. CM phi, etc. CM phi power new M minus 1. So this is how the observability up to here rank was new 1, up to here new 1 plus new 2. Coming here it is new 1 plus new 2 and so on, adding to new M. Observability index keeps increasing for the whole system. Till that time we consider. And that relative indices are the respective observability indices of, this is the observability index of output 1, this is the observability index of output 2, this is the observability index of output M. And if you do the same thing, considering C, C1, whole C, C phi, etc., and you will do C phi new minus 1. So new is the observability index. Now here many rows are, you know, dependent. Maybe that C phi contains a lot of independent rows. Here in this way, you get all independent rows only. Sorry, here I meant many dependent rows will be here. This is a big matrix. So many rows are there. M into n rows are there. Mn rows and n columns are there. So only n of the rows are independent. So this contains a lot of, garbage rows. Let me use the word garbage, that dependent rows. And this is clean matrix. First, you get this. But then this and this new, they will be equal. They will be equal. And if this new is equal to n, then it is observable. And if nu is less than n, then it is not observable. Okay, I have tried to clarify. Hopefully, I have clarified.
Yes, sir. Thank you, sir. Thank you.
Yeah, welcome. Any other question from any other learner? Okay, so I think I can thank all the learners who have, somebody has written a chat. Who can see what you share? What is that? No? Oh, there are some chats. Let me read the chats. Sir, my mic is not working. So this is from Sanup. I think his mic started working. Next is Girish. Sir, how to find observability index? This is done. So any other chat? Oh, let me use this one. Nothing, no? Yeah, so we have completed most of the questions, all of the questions in the chat also, and the live questions, whatever came from learners. So we can thank everybody for joining the live session today. And as promised, we will share the things in 2 days' time. Hopefully by Friday, we will be able to share. But we will share, even if it is late, we will share the things. Okay. And I saw that next meeting, still nobody has written any question. So I will discuss with NPTEL concerned persons whether or not that meeting will take place. That we will decide. But I have kept my day free. If anyone wants the meeting on Friday afternoon, we will have that meeting. We can have more meetings in the month of April also. March, these two we identified today and on 29th. We'll meet on 29th if required. So I thank everyone, and what to say means good wishes for healthy learning. Okay, thank you. Prabhu, are you there?
Thank you, sir.
Thank you, sir.
Yeah, so thank you. Prabhu, can we leave the meeting? Excuse me, NPTEL, Prabhu. Okay, I think I will leave the meeting because he seemed to be, there may be some audibility issues. So thanks to everyone. Thanks for joining the meeting.
Sir. Thank you, sir.
Thank you, sir.
Hello. 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 Can you able to hear me? Sir? Hello.
Yes, ma'am.
Sir, have you solved the NPTEL assignment questions?
Yes, ma'am.
Can you able to solve the assignment questions, sir?
Ma'am, the professor is already gone, ma'am.
Ah.
No one is
Oh.
here.
Sir, I'm asking you only, sir.
Yes, tell me, ma'am.
Sir, have you solved the assignment questions, sir?
Okay. Prabhu is not here, ma'am. Prabhu is went for recording. So we are coordinating the live section. Can I ask the Prabhu and let me know, ma'am?
Yeah, okay, sir.
Yeah. Otherwise, you any doubt means call Padma, ma'am. Padma will handle that assignment solution and all.
Okay, sir.
Sure. Thank you.
Okay, sir. Thank you.